So here's an example now where we're going to include a horizontal shift to our cotangent function. All right, so now when I have a cotangent function, a lot of the same things that we've dealt with in the past are going to happen here too. For example, for the cotangent function, normally if we have something in the model y equals a times cotangent of bx, our period is found just like it was for tangent, is taking pi and dividing by whatever is in front of x, right? So this is our formula, pi over b. So in this case, our period for our graph is going to be, I'll put it here in blue, pi over 3. So one full cycle would be coming from pi 0 to pi over 3. Remember, the cotangent function started at 0 and ended at pi before, so now it's going to be 0 to pi over 3. Except that there's a shift. There's a phase shift in our graph, and our phase shift can be found just like it was with the sine and cosine graph by setting 3x minus pi over 4 equal to 0 and solving for x. Well, in this case, if we do that, 3x equals pi over 4 multiplying both sides by 1/3 gives us x equals, sorry, pi over 4 here, gives us x equals, try to make that look a lot better here, x equals pi over 4 multiplying both sides by 1/3 is going to give us pi over 12. All right. So how do we use that? Well, our phase shift means that we're going to shift our vertical asymptotes in every other point to the right by pi over 12. Maybe another way of facing this is the following. If we had our basic cotangent function on the interval from 0 to pi, which would look like this, we would say that for y equals cotangent of x, we could define one basic period as being between 0 and pi. Well, we'll do the same thing right here, except that we're going to change it by taking our entire argument, in this case 3x minus pi over 4, and setting that between the limits of 0 and pi, and seeing what happens. Just like we were able to set to 0 and find our phase shift, here's what will happen for us. If we add pi over 4 to each of the three sides in this inequality, we get pi over 4 less than 3x less than pi over 4 plus pi. Well, this is 4 pi over 4 plus 1 more pi over 4. That's 5 pi over 4. And multiplying each side of our inequality by 1/3 gives us pi over 12. And 5 pi over 12. All right. So if I'm graphing this on my function right here, let's make each of these marks about pi over 12 apart right here. So let's see. 1 pi over 12, 2, 3, 4. Here's 5 pi over 12. And what we're saying is that we have one full cycle from pi over 12 to 5 pi over 12. And this is where we're going to get two vertical asymptotes. Instead of being at 0 and pi, they're now at pi over 12 and 5 pi over 12. What's more, we know that the period is pi over 3, and if we did take the difference right here, we would find pi over 3 is the period. So if I added pi over 3 one more time, let's see, 5 pi over 5 pi over 12 plus pi over 3. Let's see, pi over 3 is the same thing as 4 pi over 12. So this is going to be 9 pi over 12, right? Pi plus 4 more, so 4 more, 9 pi over 12. 9 pi over 12 reduces to 3 pi over 4, which would be the next key point right here for a vertical asymptote. Kind of interesting that these numbers work out this way, but there it is. Okay. What happens at each of the key points? Well, within one interval, starting at pi over 12, ending at 5 pi over 12, where we get another vertical asymptote, we're going to get 0. I'm sorry, we're going to get a vertical asymptote here. We're going to get a vertical asymptote here. We go by quarter points. So what's 1/4 of our period? Well, 1/4 of our period is pi over 12. Here's 2 pi over 12, 3 pi over 12. So pi over 4 is halfway through our period. At pi over 4, we're going to get 0. If we go to our quarter period to the left right here, let's see, pi over 12 plus 2 pi over 12, that's pi over 6. Pi over 6. And then 1/4 period past pi over 4 is going to be, let's see, this is 3 pi over 4, 5 pi over, so, sorry. This is going to be 4 pi over 12. And that's going to reduce to pi over 3. Here we are. Pi over 3 is the next quarter point. So what happens? Well, because it's a cotangent function, we're following this pattern where it's going down. That means at pi over 6, we're at positive 3/2. And at pi over 3, get rid of that other piece. At pi over 3, we're actually at negative 3/2. So let's see if I'm marking off each of these as 1. 3/2 is right about here. Negative 3/2 will be right about here. And these are our quarter period points right here. Pi over 6 at this point, and pi over 3 at this point. And so one cycle of my cotangent function shifted to the right looks like this. And we repeat that same pattern over and over again. At a quarter period, we're at 3/2. At half of the period, we're at 0. At 3/4 of the period, we're at -1. Then we go down towards the vertical asymptote. So we get another branch of our graph that looks just like the first one. And we just keep repeating this over and over and over again for as long as we need. All right. So this should give you a good idea how we're going to graph something like a tangent or a cotangent function.